for our next talk, I want to bring on Elena to tell you about how we actually loop in privacy with all these things now that are happening on chain. So please give Elena a big round of applause.
Awesome, thank you. Cool, yeah, no, it's great because my first entry point into crypto was actually the 2017 ETH Waterloo hackathon where CryptoKitties actually debuted their entrance, and so it's really cool to go right after him. Cool, so I'm going to talk about cross-chain privacy pools and how we can introduce that for EVM chains. So why make a really big deal about privacy anyways? And so embarrassingly, I actually thought this entire conference was at a different location, but it's not. It's actually here. And this is actually a great segue for the importance of private money. So private money during World War II was actually diamonds. Diamonds are a pretty great source of private money. They're portable, they're small, they're universally accepted, and they're actually a pretty great store of value. They're actually pretty private as well. So if I give you a diamond as a sort of like a form of payment, then there's no like public ledger that records that transaction. So it makes it pretty private. And it's a pretty great choice to kind of safeguard your money when the government is out to confiscate all your bank accounts. So it was actually indeed used by Jewish people during the 1930s, 1940s, when they were trying to cross borders. But the lesson here is that privacy actually does matter. And so when we think about cryptocurrencies, there's actually a lot of similarities between diamonds and cryptocurrencies. Both are portable, both are great stores of value, and both are, somewhat decentralized. Right now, pretty much all of the top cryptocurrency projects are fully transparent, and so all transactions happen out in the open, which kind of leads to a pretty dystopian world. And I think we can all agree that the biggest product market fit of crypto is indeed stablecoins. I've used USDC, USDT way more than I've used pretty much anything else. And again, everything that we do with stablecoins is transparent, and so if we kind of fast forward this world and we can assume that crypto payments is being used for everything, it does lead to kind of a weird dystopian future. I can look at anyone's account. I can track my friends' accounts. I can look at anyone's wallet on EtherScan. And even if you try to use multiple wallets across multiple chains, we still have pretty good infra companies that can actually aggregate all that information. And so we know exactly how much crypto Donald Trump has, for instance, across many, many chains. And so crypto is not new to privacy projects. There's actually been tons of attempts at making privacy for crypto work, and it still doesn't work. There's not really a solution for me to use right now. If I wanted to send $20 privately to a friend of mine using crypto, I'm not entirely sure what I would use. And I'm not saying that there aren't solutions. There are lots of companies, lots of projects that are trying to solve this problem, and they're getting there in different ways. But right now, it's actually still pretty hard. I would have to kind of ask the question of okay, if I want to send USDC privately, what protocol do I use on what chain? What asset do I need to do, or what asset do I need to use for that transaction? If I send $20 versus $100 versus 1 ETH worth of money, do I get different level of privacy because some protocols actually do rely on that? And is a project fully decentralized? If I use a project, will I get in trouble? Will I get in trouble using a privacy pool, or will the project disappear because of regulatory concern? And so right now there actually isn't really a go-to solution for privacy in general, and we really hope to change that. So that is exactly what Ironfish is trying to solve for. We are trying to make a cross-chain privacy layer so that all EVM chains can have access to a privacy layer for all their assets. So this talk is really about what are the ingredients that we used in particular to get there, and I'll kind of walk them through pretty quickly, but I want to kind of give you the intuition of why privacy is so hard and why there are so few projects that are actually making this achievable. So the first ingredient is what we call Ironfish MASP, which stands for Multi-Asset Shielded Protocol. And the second ingredient is Multi-Sig wallets, which for what it's worth, there is currently no privacy chain in production right now that has full private multi-sig wallets. And so even though it sounds like kind of a small thing for other chains, technically it's actually very hard to achieve for privacy. And then the third ingredient is Custodian bridges that actually connect Ironfish to other EVM chains in a way that protects Ironfish from bad actors. So we are partnering with the Custodian bridge so that the bridge actually does monitor all transactions that go into Ironfish to make sure that no bad guys actually enter Ironfish, and if they do, their funds are frozen. Cool. So what all of this combined, all these ingredients lead to what Ironfish is today, which is it's currently live. We actually have been mainnet launched since April of last year. So it's a layer 1 proof of work, very vanilla, but it's a full privacy chain. It's fully decentralized. We have nodes all around the world, and you can run our node app right now and easily connect to the Ironfish network. And we support wrapped bridged assets so that you can have private wrapped USDC from Base or any other EVM chain on Ironfish in a totally private way. You can kind of think of Ironfish as one privacy pool for all assets across multiple chains. And the bridge partner that we have does full sanction screening and more so that the bridge protects the privacy layer itself. Okay, cool. So let's dive in on how all this works, because Ironfish does not have smart contracts, and yet we can achieve all of this. So I want to go over the Ironfish multi-asset shielded pool very, very quickly to kind of give the intuition of how it works, even though, again, we don't have any smart contracts at all. So the key generation is fairly complex, but you can kind of think of Ironfish as having really 3 keys. You have your secret key, which is the same concept you have in Ethereum. You have your public address, which is how you request money, but you also have a view key, and a view key lets you give an auditor or somebody else full access to your transactional history. And then even though Ironfish is a UTXO-based system, we do support custom assets. And the way we do that is you can actually define an asset on Ironfish, and it is fairly limited. For instance, it doesn't have like a full ERC20 Solidity example, but you can still give it a name, metadata, creator, et cetera. And we actually use that information to create what's called an asset generator, which is a point on an elliptic curve, which we'll then use to balance the equation. So even though the equation is fully encrypted, you can't see that the sender recipient or the amount, or even the asset type, we can still balance all of that out in the end. So if you're familiar with Bitcoin, Ironfish is similar in the sense that it works on a UTXO-based structure. Unlike Bitcoin, we do give you more optionality, so you can, again, give a note of an asset effectively, and a bunch of other information to help us make it more useful. And then the way pretty much all privacy projects work is very, very similar. So the idea is that you have a global Merkle tree of notes, and all the notes are encrypted. So for instance, this is kind of a Wikipedia page, a very classic example of a Merkle tree, and this is basically the global data set of all notes ever created for Ironfish in their encrypted form. An Ironfish transaction has basically 4 functionalities. So again, even though we don't have smart contracts, we give you functionalities for how you can spend or create new assets. So you can spend assets, you can create new assets, you can mint them, and you can burn them. Effectively, the way it works is a spend is always private, and an output is always private, meaning that I can always spend my money and I can give you money in a way that nobody sees. But the mint and burn operations are actually public so that you can see if a bridge operator, for instance, is acting honestly and not printing more money than it should. So cool. So for a spend description, all I want you to get out of the slide is that everything is fully encrypted. So if, for instance, on EtherScan, you can literally see exactly what's being created. Here on Ironfish, everything is encrypted. And instead, we have a zero-knowledge proof that verifies that even though the transaction is encrypted, that I'm spending this money, it's still accurate. And so the TLDR of what a spend description does on Ironfish is it says, there is a note in that Merkle tree that I showed you earlier. I am the owner of it, and I am revealing a nullifier to you in a way that was constructed honestly, such that such that I'm not able to spend that note again in the future. So there's no double spend. An output description is very similar. Again, it's fully encrypted, so only the recipient and the sender sees that information. And there is a zero-knowledge proof attached to it that basically says that I, as the sender, have created this output note for the recipient in a way that they can then spend it in the future. The mint description is very, very similar, except that it does have public information, so we can kind of audit the chain and make sure that bridge operators are acting accordingly and not creating more money than they should. And then the mint description, the zero-knowledge proof around it just says I'm allowed to print more of this asset. And then the burn description doesn't actually need a zero-knowledge proof at all because anyone can burn an asset if they choose to. And so the important part of this is that every transaction comes with, or every description, I should say, comes with a value commitment of how much of an asset we're spending or creating. And this is important because we actually use this to balance the equation. So a transaction that can have wrapped USDC or iron or pretty much any other asset would still balance based on the fact that we use value commitments and elliptic curves to basically guarantee that even though a transaction might have hidden assets, everything still balances as it should. Cool. And now we have multi-asset shielded pool. So this is kind of an example of, even though we don't have smart contracts, we can still actually have multi-asset protocol in a completely private way for people to create custom assets, and a transaction does not reveal whether or not there's any custom assets in it at all. Everything's fully encrypted. Cool. So the next ingredient is, how do we create multi-sig wallets? And we implemented something called Frost DKG, and Frost is a threshold signature scheme, and DKG means that it's decentralized key generation, meaning that there's no central party that is responsible for helping you create the multi-sig. Everything is done in a fully decentralized way. And so the TLDR of that is, it's the ability to create a fully private wallet without a central dealer, and you can create a wallet such that you can require N of K signers for a transaction to go through out of a wallet. And so if you combine all these ingredients together, this is actually a demo of testnet to testnet. You can literally use a bridge to send an ERC20 from an Ethereum testnet to Ironfish, and you can have a wrapper representation of that asset on Ironfish. This is the Node app wallet that kind of shows you that there is indeed a wrap representation of the ERC20 coin that originally was on Ethereum, or on Sepolia really, and you're able to have it be on Ironfish, and then you can also send it back. So this is something that is currently being tested out in testnet to testnet, but we are really hoping to launch this soon, and we're working hard on launching Ironfish to pretty much all the popular EVM, L1, and L2 chains, so that any asset can have access to a privacy layer. So this is coming soon, and if you're interested, you can always follow us on Twitter for more info. All right, thank you so much.